Well, we would like to have the panel discussion from here about line computer vision research as is and to be. Please stay with me for 40 minutes, everyone. Thank you very much. First of all, I would like to introduce myself. I actually got the degree of the computer vision long time ago. I'm teaching at Osaka University right now, but I am a technical advisory of a Line AI company, computer vision AI technological discussion I am having, and I'm going to be the moderator for this session. On the July 1st, the Line established the computer vision lab within the AI company. So we have the experts of the computer vision and then doing the development of the technology and also thinking about the business development. So I introduce the Mr. Ijiri, who is the head of the lab. He is an old friend of mine. And we have the Okao vision, the face recognition development and the business development he has been doing both. And he came to Line in July, and he is head of the computer vision lab. So research and the business, he does both as a Superman. And this is Mr. Fujiwara. He is a wine lover. He likes drinking, but he got the degree of the computer vision. And he will be explaining the geometric information analysis. He's an expert of that. So he's going to talk about that, geometric information analysis. The key word is the most advanced research is done. And also we are thinking of the business development beyond that, and everyone is paying attention to that. Okamoto-san is here. He is actually the rugby player, the uniform number 14, wing. He's a ruggerman. And on the other side, he is an engineer. So two-way player is very hot. There are a lot of needs recently. So he is very physical and technical. And his area is pattern recognition in image area. He does the technological development and the business development at the same time. So he is going to talk about that, mainly document analysis. Here's the agenda. In the first part, Line computer vision technology accomplishment we have made, including the academic conference. And the latter half is a multimodal technology, basically document will be explained. So we go to the Line computer vision. What kind of technology it is, Ijiri-san? Yes. Thank you for giving me time and explain the computer vision technology. It is not easy to explain, but the visual, the technology which imitates a human visual recognition. So what we do is the most of the tasks are depending on our visual information. So it can help or it can replace the human tasks. So if it's possible, we can automate the people's task and then lead to the DX. So this is very futuristic for the business as well. So geometry, optics, the modeling of the image process, but we have the pattern recognition and the deep learning technology coming. So it includes every in image analysis technologies. So we have various applications being developed. For example, on this slide, left-hand side, we have the face recognition. Very accurate recognition is possible to identify the people which can be used for the gate. And in the middle, we have the global OCR. This is a characteristic recognition technology like slips or invoice receipts can be read, and we can proceed the digitalization of those. On the right-hand side, we have a global vision. This is the object detection and the image search technology. You might already know in line shopping, well, there is a shopping lens technology. You use a smartphone and take a shot, take an image, then the product can be identified and it can be purchased very easily. So mainly using the smartphone, there are a lot of applications people can use. And for the DX or identity verification, there are the enterprise use cases coming out recently. So we can improve the response and support for the domestic companies. And as introduced before, we have the Computer Vision Lab in this July. Wow, that's great. CV Lab, Computer Vision Lab, is now being established. So LINE's computer vision research has been done. So people might think that voice or natural language when we say line, but we have been doing the computer vision researches along with that. So it is getting hot. And when I was young, it's so different. The landscape is so different. So Ijiri-san? Yes, that's right. As you can see on this slide, this shows the progress of the computer vision researches. So this is a computer vision pattern recognition. The top academic conferences, it's the number of the submission of the thesis. Since 2017, the number is increasing. So in this image analysis area, 2012 was a breakthrough year. And then there has been a lot of the applications thought about and then solve a lot of social problems. So engineers and the researchers are now interested in this area and do the various kinds of researches. Along with that, it's getting more and more competitive, and the speed of the change is quite fast. Yes, thank you. When I was young, it was not that hard. Yeah, I came to this industry in 2002 or 2003. There were 1,000 theses, but now it's 7,000, so 7 times. But in Eto-san's days, it was a long time ago than that. So I was the first author of the oral presentation in ICCV conference. It was right after the before wall collapsing. So that was 1993. So we have some 100 of the thesis. So 500. In 1996, there were 500. So it 14 times since then. So it was good old days. So this kind of conference is great. It has so many theses. Yes, I said it's competitive right now in this area. And we have the impact factor, which is the index based upon the citation of the thesis. It shows the importance of the academic conference. So it's been taken by the Google. So from the top, we have the Nature and Science, well-known journals. So we have colors here that are related to computer science, AI, computer vision areas. So they are ranking on top. So when you see the pink color, this is related to the computer vision conferences. So as number 4, we have the computer vision and pattern recognition. And it is right now comparative to the nature and the science. So it becomes more and more important. And the next one, line 31, ICCB conference. So it's once in 2 years right now, but if it takes every year, the number would be much higher. So it's comparable to CB and the PR. So computer vision has the same impact as nature and the science. That's great. And to this conference, Fujiwara-san, Mr. Fujiwara, submitted 2 theses. That's great. So, Fujiwara-san, please tell us what you did. Yes, thank you very much. So, we have seen the statistics and the CBPR of the last year. And in the ICCB, our group submitted the thesis, and the 2 were accepted. The Matsushita, Professor Matsushita team of the Osaka University, and we have the poster and the oral presentation. So this is useful to analyze images that are taken from the multiple point of view. Okay. So first, oral thesis, GSLR. So in the area of the computer vision, it analyzed the visual information and tried to extract the useful information. And the visual information media, you can think of the camera and then pictures taken by the camera. And then this kind of data is not so hard to handle because there is a determined coordinate system. We know where is the origin, and then we can tell right and left. And also the pixel sequence is regular. So we can use the various algorithms to do the analysis easily. But space information, in order to know that, we have to have the point group information of the 3 dimension. But in this case, we cannot use the convenient characteristics as coordinate system changes if it turns, and order of the point is any order. So even though the order changes, rabbit is still rabbit, and it's difficult to handle as data. Okay? And furthermore, in order to analyze the space information taken from various directions, we have to consolidate it and show it on the one coordinate system. So by conversion to minimize the spatial error between points, we should understand this conversion. Conversion means the move. And because of the point group characteristics, it is very difficult. If the object is very noisy, we do not know how we can understand the relationship of these. So that is a problem. Okay. So very simple problems. We think of this situation. We have A and B, and each of them is point group, and we try to find out the X, conversion X. So ideally, the same thing are shot in the same situation, only the posture is different. And we need conversion X to minimize the gap of each line, and that can be defined as a linear regression question. You have seen it before in some text. So here we have the point A and the point B. We know the relationship between them. But realistically, that kind of situation is rare, only in the computer graphic area. So in order to solve that, we have the shuffled linear regression. So we, of course, need the conversion X, but at the same time, we can put the permutation matrix. So even though we don't know the order of A and B, but using the P, we can figure out the combination and try to optimize the conversion. So the location of A and B lines are changed like this. But there is a pitfall for this one. Can you tell? Well, we can get the order, but the A and B are supposed to be the same number. So as shown in the picture, if there is a noise, it collapses. Okay. So in this research, we generalized the shuffled linear regression, and then it can handle the change of the order and the outlier. We have the generalized shuffled linear regression. So if we lose the restrictions of shuffled linear regression, so we maintain the permutation P, and we can define it, and we have proposed it as a new problem. Okay, so we have the video for that.
Corresponding pair number K and a permutation matrix P and transformation X. These are gradually updated so that it will come to the most appropriate solution. So can I play the video? Yes, go ahead. As you can see, there are two dragons which have two different missing points. So applying the same method, the corresponding pair number K, permutation matrix P, transformation X are gradually updated, and now both of them are in the same attitudes. So we've been using a point cloud, but we can also apply this technology for the pure image and getting the image from different angles, and we can produce the perfect reproduction. So that is about the first video. That's cool. Thank you very much. I'm impressed. So another issue is the attitude problem that I pointed out at the beginning. So deep learning is a trend right now, and it is used for the point cloud analysis, and also you've seen the great development there. But up to now, the hypothesis is that you are given the attitude. For example, the chair is always showing the frontal part of the chair to us, so that when the attitudes are different, then you can't really work on it very correctly. So this is a chair. So whatever the direction is, the upper portion is right facing, the lower part is left facing. So point cloud, which have the same object, should be understood as the same object, whichever the attitude is, so that we use the main element analysis, and the axes are produced from there, and then using those axes, then we can set the attitude and try to make it learn that type of the images. So ad hoc method. So we tried many things, but the main element analysis has been studied in detail, and I usually put the sequence from the more distributed one to the less distributed one, but it was not really best in recognition, because in case of plane, due to the size of wings, these axes or the orders can be changed, so that just using all three axes of PCA can be used for the learning so that we can improve the accuracy much better. So it was a surprise. So that was the first one. That was the first one and also first contribution. So that was a surprise. But we try to understand that which attitude is most appropriate for the identification. So out of 24 different attitudes, we propose a module to select the most appropriate attitude. And then this can be applied for any type of the deep learnings, especially good for real data. This is the second thesis. So listening to your presentation, I'm very much impressed, but what about the application of this technology? This can be used for the image. So multiple cameras take pictures, and also we can analyze the object and also the people very accurately. Let's say this is a bird's eye view so that you can see only part of the people's face or only part of the object. Not really overall figures, but by integrating different cameras, pictures, we can really analyze the object and the people. So you can use it for surveillance camera. Ijiri-san, I'm sure that you have something to say, right? Yes, I used to work at the manufacturing area, so that when I think of the application, 3D detection or alignments or matching or search, these things can be very useful in the manufacturing. NAVER has a great robotic technologies. So by combining the two, I think we can use it for on-demand pickings at the logistics company, like individual shipping can be done automatically with this type of things. Okay, so this methodology is very simple. When I first read this thesis, this can be used in a very fast speed. So I think it has been well understood in that way. What do you think, Fujiwara-san? Yes, I agree with you. The methodology was very simple and realized the result and produced the outcome. So I think this is close to the application. I think it is great that the research is directly related to the business. In the past, research and businesses were all separated, but now high-quality research can be really implemented in the business. So let's move on to the next agenda. So that we've been talking about the computer visions and also its improvement. Let's talk about the future direction of the CBL. How are you planning to improve the 3D technology? I think Fujiwara-san should start. Thank you. So the research that we talked about was about the still image or 3D image. But the still image is very limited. We are always moving, and the information with action should be also studied. So that's why we are working on it. For example, to produce 3D CG, creating the animation, they're suffering from the lack of the people, so that with this type of tool, we can help the people to produce a good content. I hope that this presentation can be done by my avatar. And also, so not just a tool to control, but if I say jump to this object, and then this object can jump in the CG. So my thinking is that if I can give the oral instruction to this type of content, that will be intuitive and it will be great. Yes, it is great because Line has AI technology and also natural language processing technology. So we can integrate them and we can really produce a great third applications. For example, the on-demand 3D model communication, commercials, TV program, content creations will be dramatically transformed in the future. And also newscasters and also sign language, translators. We can really do that on demand. So that would be great applications. We can support many people. And also, I think that LINE can manage digital talent agencies. So that can be the future. So natural language processing and also voice synthesis will be combined, and it will be very important and also interesting applications. Well, 3D used to be far away seen, but now we can work on them. I'm very much impressed too. Okay, for the latter half of the presentation, we will be talking about the multimodal, the combination of the several information. But let's start from 2D though. Character recognition is old, but yet it is still a challenge for us. So, Okamoto-san, I think you have prepared this photo, right? Why don't you start? Okay, my name is Okamoto. I'd like to talk about OCR. Eto-san mentioned that the OCR is old. It has been studied for quite a long time. And some may think that OCR is already established technology, but no, it is evolving and also high expectation from the users. For example, if you look at this picture on the left-hand side, now there is a crumpled paper and you have to read the text on it. And also the right-hand side, that the informations are structured into this structured information. So these are the theme of the research. So if we can do this, then we can read ID, we can scan the ID paper, or we can scan the vaccine certificate. Well, yet the accuracy should exceed the certain critical point, right? How do you really make that accuracy great? Yes, it's a great question. And as I said, if you scan and identify someone's ID certificate, just one error can be a big problem, so that we make sure that the performance should be 100% or very close to 100%. So I want to re-emphasize that certain application really needs 100% performance. So OCR it's very, very high-end technology, and then we've been still fighting against it, so that your journey of the OCR performance is still going on, right? Yes. So I'd like to talk about the strategy, how to really improve the performance. So please show the next picture. So that is multimodal. As I said before, information should be really extracted in the structured information model, and also key information extraction is very important. It's been popular even in academia, so please look at the animation. I think you can guess what it means, but just a vision cannot really extract everything. To have 100% performance, vision itself is rather limited. So that's why multimodal comes in. This is not just about the vision, but also you have to have the language information. So when language information comes in, what would be good? For example, if you look at the document, you find the word price. And when you find the price, usually followed by the dollar, yen, or numbers. But these knowledge are the language knowledge. So you can predict that what's coming after price. And also, if you find a word like a TOEFL, which is not a word, then you can guess that maybe this is total instead of TOEFL. So this type of things can be done only by combination between multimodal method, so that the vision plus language knowledge. Okay. So the image recognitions will be integrated with natural language knowledge. So I understand about the direction, but would you elaborate on it? Yes. What I'm showing on the screen is that the knowledge which can be helpful for the OCR improvement. As I said, the character recognition or combining with the language knowledge, upper portion, the common knowledge, has these universal knowledge. But if you look at the lower half, the customer-specific knowledge are not well utilized yet. So customer-specific knowledge means the production numbers or product code or description rules or document format. These are customer-specific knowledge. So you may think that there are so many things which can be integrated into the multimodal technology so that we can improve the performance. But one point, you have to be careful. If you start using so many different knowledge, then it will take time to develop. So we have to make sure that we have to be agile. We really have to teach the knowledge at the site, or maybe we can use AI. AI can learn itself about these customer-specific knowledge or create a very strong basic model. So these are the strategies that we are currently thinking. So what are the assets for this technology? I think we have a great asset inside Line, so we can realize this. Yes. The natural language processing and also integrating all these different things in a multimodal technology. I don't think that not many people have tried this. So it is going to be very interesting domain of research. Thank you. So, Ijiri-san, I have a question to you. So OCR is a character recognition, and you have to really think of different application to utilize that function. So looking at this picture, Ijiri-san, would you like to explain about this? So what is a future that we are really aiming? I would say digital transformation is our future, but we have to bring in lots of innovation in there. So you may not understand what it is on the screen, but this means that the contract is sent from this person so that the revision can be made automatically. Let's say application form is submitted and there are some error on it, then you have to revise it. It takes 1 or 2 weeks right now, but it can be done instantly in the future. The individual have to give the signature on the contract, or the corporate have to conclude some contract. So the digital form or the digital department can really do the legal check automatically, so that based on the past contract format or contract information, the machine can check legal matters like this. And the next one. So along with that line, whether it is individual or corporation, they have to deal with so many different documents. So some documents have only text, but PowerPoint and an Excel, graphs and tables and then images and also pictures. There are so many of them. So even though you understand that you created it somewhere, but you can't really search it because images has text in it. And then text in the image has not been read, so that's why you can't really research. So if you go beyond the modality borders, then you can actually read the text on the PowerPoint or the picture. So if you can do that, then the information and the data that we have accumulated can be utilized at the maximum level. So if we can do that, we can produce wonderful ideas, or we can think of great solution for a problem. So listening to you, so character recognition means that you understand the sentence. So you thinking of understanding the chapter or sentences, then the character recognition is a part of it. I think this is a very logical way of evolving. Okay, so we talked about nature, science. Well, the ICCV is the almost equivalent to the natural science, and your thesis has been accepted by the conventions. I think that the line has a great capability in many areas. So image recognitions and also multimodal world will evolve in the future. But you have to have some outcome. So I would like to have your commitment announcement from 3 people. Ijiri-san. Well, thank you for your pressure. I can't really find the good words, but I produced this slide, what I wanted to do. Mixed line AI, that is abbreviated as Mirai, the future. We discussed about multimodal technologies, but multimodal input, multimodal output, so multi-dimensional DX will be possible. That is our future. So we have NLP, the speech, voice, computer visions. We have great AI assets so that we can fuse them, integrate them, and can create very interesting ideas. So with this great research team, as Fujiwara-san said, that we really want to produce theses on the top conferences and AI research, and also another excellent research will be pursued. Then Fujiwara-san, thank you. Well, COVID pandemic will be subsiding, so that let's write thesis will be passed, then we can celebrate it with a drink. Nice. Great. That's a great commitment. You write a good thesis. But if you write a great thesis, that can be applied for the business, so that's great. Okamoto-san, you're the last one. Well, thank you very much. Okay, my commitment is that I'm going to make Line platform is going to be the part of the people's daily lives. So we discussed about the multimodal strategy, but I really want to achieve the 100% performance so that our platform is going to be essential to the people's daily lives. So that I hope that you will keep supporting us. Okay. There's not much opportunity to study the multimodal technology, so thank you very much. That was a wonderful closings. Okay, so let's conclude this panel discussion. Well, thank you very much for staying with us until the end of the session. Thank you.